Hey kiddos, this is the Spiral Review for Spiral 2. I'm going to go through the problems that are labeled video to help us make some sense of this. Okay, first of all, we've got three different functions going on here. We've got an equation labeled f, a table labeled g, and a graph labeled h. So we've got to be able to tell which is which. For problem 1, the video part is going to be to find f of 3. So first thing we do is to identify, f of 3 is there twice, that's fun, to identify what's going on up here. And I've got f of x is the equation, so we're going to use that equation. So f of x is x squared plus 2x. Just want to make sure I copied the equation down right. I did. Good. F of 3 means I'm going to plug in x equals 3 to my equation. So f of 3 is going to be 3 squared, really important to use parentheses there, plus 2 times 3. 3 squared is going to be 9. 2 times 3 is going to be 6. The answer to this is 15. For problem number 2, I've got to find h of negative 2. That's the video part of this. First thing I do is identify which of these is h, and that's going to be my graph. So I need to interpret what this means. H of negative 2 means the height of my graph when x equals negative 2. Okay, going over here, that's over here. Here's my graph. That appears to have, okay, there's 0. This has a height of 1. So h of negative 2 is going to be 1. For number 3, I'm not doing a video. For number 4, I am doing a video. So let's take a look. If h of x is equal to 2, okay, we're back to our graph again. So this means we're talking about the height equals 2. Identify all possible values for x to make this true. So anywhere that has a height of 2 on my graph, that's going to be anything that has a height of 2. And it looks like I've got 2 places. The first, well, if that's 1, this is going to be at 0.5. So that's one of my answers. That means that x equals 0.5. And then looking a little bit over, so if that's 2 and 4, that's going to be 3. And it looks like I hit exactly at 3. And x could also be 3. So there are 2 answers for that one. Number 5 is the next one. I've got to place these values in increasing order. So let's go piece by piece. So f of 0 is going to be 0 squared plus 2 times 0. That's my equation, and that's equal to 0. G of 0, we'll get to use my table. That's going to be the output when x is 0, so that's 2. And h of 0 is going to be the height of my graph when x is 0. So that's here. We've got a height of 1. So in order, we've got f of 0, h of 0, and g of 0 in increasing order from smallest to largest. On to the next topic, we're talking about characteristics of graphs. And same idea here, I'm going to take a look at some of these specifically to do as a video. And for this problem, we're really looking at the first of these 2 graphs. I'm going to do each of these pieces for this video. Okay. First, we've got to find the domain and range of the graph of h of x, which is given to the left. Hey, this looks like the graph on the previous page. I know for domain, we're talking about x values. And that I've got to find the first x value, that's going to be negative 2. I've got to find the last x value, that's going to be 4. And to use an interval, I'm going to put a comma between them and put a couple brackets around there. Just as a side note, this means the same thing as negative 2 is less than or equal to x, is less than or equal to 4. In other words, x is between negative 2 and 4. For the range, we're talking about y. We got to find the lowest y value, which is going to be 1, and the highest y value, which it looks like it's going to be 3, and my interval is going to be from 1 to 3. This would represent 1 is less than or equal to y is less than or equal to 3. Second question here, is h of x a function? I know it's a function if every input has only one output, and we have a kind of short way to do this called the vertical line test. If I can draw vertical lines and never hit this twice, we officially have a function. I'm going to undo a bunch of these so it doesn't mess up my picture. And in that case, I won the vertical line test, so I can just say yes, and I'm okay with you just writing vertical line test as the answer. That gives you an idea of how this works. Sorry about the bell. In order to identify increasing intervals, we have to remember that increasing, we're talking about something that looks like it has a positive slope. In other words, going from left to right, we're going up. We've got to basically identify the places on this graph that are doing that, okay? And to me, that looks like this interval here. So for increasing, we're looking at an interval from 0 to 1. We always use x values for increasing and decreasing intervals, just to describe the x's where these are happening. For decreasing, we're looking for part of our graph that's going down and to the right. That's going to be this part here. And the x values for that looks like we're starting at 1 and we're going to 4. So my interval would be from 1 to 4. Positive, we know, means above the x-axis. The x-axis is here. My entire graph is going to be above the x-axis. So that's going to be from negative 2 to 4. And again, that's going to be an interval notation. Negative intervals means below the x-axis. And because there's none of this below the x-axis, there'd be none. To identify one relative maximum or minimum on h of x, we know that relative just means the highest in an area. We're looking for something that looks like this, where we have some kind of a peak surrounded by lower things. That looks like here. So we're looking at x equals 1, and that point, if you wanted to write that, would be at 1, 3. It would also have a value of 3. You could also write this as h of 1 is equal to 3. Relative minimum. The only relative min we could really talk about would be this guy, or I guess any point along the constant part, but we're not going to go there. And this is not an ideal relative minimum because it's an endpoint. So let's focus on that relative max.